So our topic for today's class is the number of roots of a quadratic equation. We are going to see the nature of the roots of a quadratic equation. If f of x is a function, then we call the solutions of this equation f of x equals to 0 as the roots of f of x. Meaning, if I have this equation, and if I'm going to solve this equation, I'm going to get there's a possibility that I'm going to end up getting two values of x because it's a quadratic function. So what does root mean? Root means that you're going to equate your function to 0. Basically, on the graph, the roots are the x-intercepts, the points where the quadratic graph is going to intersect the x-axis So if I ask you to solve this equation, do you agree? Let's apply the quadratic formula to solve these equations. So the quadratic formula was minus b plus minus square root b square minus 4ac upon 2a. Do you remember this formula?
Yes, sir.
So if your equation is in the form of ax square plus bx plus c equals to 0, the values of a and b can be picked from the equation. Minus b, which is 2, plus minus square root b square minus 4 times a times c over 2a. So minus 2 plus minus square root 4. So what is this going to be? Square root of 36. So minus 2 plus minus square root of 36 is 6. So you end up getting two values of x, that is minus 2 plus 6 upon 2 and minus 2 minus 6 upon 2. So x comes out to be 2
2 and negative 4. Negative
and
4 and 2.
negative 4. Okay.
4.
Now, okay, if I solve this equation, the second equation using the quadratic formula, it's going to be minus b plus minus square root b squared minus 4 times a times c divided by 2a minus 6 plus minus, what is the term inside the square root going to be? 0?
Just give me a minute. It will be 0.
0. And minus 6 plus 0 upon 2 or minus 6 minus 0 upon 2 leads you to the same answer, that is negative 3, right?
Yes.
Now, if I solve this third equation using the quadratic formula, it's going to be minus 2 plus minus b squared minus 4 times a times c divided by 2a. So, is this equation going to be solved?
Two twos of 4.
Can this equation be further solved?
No.
No. Now, what's the reason this equation cannot be solved? Because in the square root, you have a negative number. So this equation will not have any real roots. So this equation will have no real roots, meaning the x values there is no x intercepts. In the second example, you were getting x equals to negative 3. So that means the roots are real because you are getting a value, and they are equal because you get from both sides, you are going to get the same results. So that is real and equal. And for the first example, you were getting two different solutions. So the solution or the roots are real and distinct. Distinct means different. Now, what affected the nature of the root. This is called, these are the nature of the roots. Real, either the roots can be real and distinct, or real and equal, or they may not be real. The deciding factor is the value of the discriminant. The value of the discriminant. Over here, the discriminant, over here, so what is discriminant? Basically, b square minus 4ac is referred to as the discriminant. This value decides whether your roots are going to be real and distinct, or your roots are going to be real and equal, or they are not going to be real at all. So if the value of the discriminant b square minus 4ac is positive, then you can see that there were two different roots, they were real and they were different. If the value of b square minus 4ac is 0, then the roots are real and equal. And if the value of b square minus 4ac was negative, less than 0, then the nature of the roots were no real roots. Okay. Now, what is the meaning of this? If you plot the graph for the first equation, there are two x-intercepts. There are two different x-intercepts, -4 and 2, meaning that the x-axis is going to intersect, the curve is going to intersect the x-axis at two different points. For the second example, your curve is touching the x-axis at only one point. So we say that x-axis is tangent to the curve, because a tangent line is a line that touches the curve at only one point. So x-axis is the tangent to the curve. And when the x-axis is tangent to the curve, this means that it's going to touch the curve at only one point. Hence, the root is real and equal. There is only one root, real and equal roots. When the discriminant value is negative, you are not able to find any real roots. So that means that the curve is not going to intersect the x-axis. It is entirely above the x-axis, or it can be entirely below the x-axis if it was a negative. If it was a maximum curve, then in both the cases, the graph is not intersecting at the x-axis. That's why you have no real roots. And when do you get no real roots? When the value of the discriminant is negative, meaning less than 0. When are you going to have real and equal root? When the value of the discriminant is equal to 0. And when are you going to have real and distinct root? When the value of the discriminant is positive. Okay. So if I want to complete this, to summarize this, can I say that if the value of b square minus 4ac is greater than 0, then the nature of the roots are going to be real and distinct. If the value of b square minus 4ac, which is the discriminant of the equation, is going to be equal to 0, then the roots are going to be real and equal. And if the value of the discriminant is less than 0, then we are going to have no real roots. Is this thing clear to you?
Yes, sir.
Sure.
Yes, sir.
Okay. So what is the meaning of real and distinct root? It means that the graph is going to intersect the x-axis at two different points. If you have a minimum curve like this, then it's going to intersect like this. If you have a maximum curve, then this is going to be the sketch. But this is the condition. When can you have two different roots? When the discriminant b square minus 4ac is greater than 0. If the value of the discriminant is equal to 0, meaning b square minus 4ac is equal to 0, then your quadratic curve is going to intersect the x-axis at only one point. So we can say that the x-axis is basically the tangent to the curve. Your x-axis is tangent to the curve. And when the value of the discriminant is less than 0, then that means that you're not going to have any real roots. No real roots means that the graph is not going to intersect the x-axis. If it is not going to intersect the x-axis, that means it is going to lie above the x-axis or below the x-axis, depending on if it's a minimum curve. So if it's a minimum curve and the minimum point lies above the x-axis, then that means that the entire graph is going to lie above the x-axis. If it is a maximum curve and the maximum point lies below the x-axis, then that means that the entire graph is going to lie below the x-axis. So there is no intersection between the curve and the line and the x-axis. So there are no roots. Okay, is this thing clear?
Yes, sir.
Okay, I want you to note this down. Find the values of k for which the equation 4x squared plus kx plus 1 has two equal roots. What do we understand by the term word two equal roots?
Both roots are equal.
Yes. So what case was it? When do you get two equal roots? When the discriminant of a quadratic equation is
Equal.
equals to 0. So if the discriminant of the quadratic equation is equals to 0, then you're going to get two equal roots. So we need to find that value of k in this quadratic equation for which the roots of this equation is going to be equal. So this equation is in the form of ax squared plus bx plus c. If I want this equation to have two equal roots, then the discriminant of this equation must be equals to 0. What's the value of b over here? In the equation, notice that the value of
Okay.
b is k, the value of a is 4, and the value of c is 1. So this gives you k square minus 16 equals to 0. So what is the value of k? What are the values of k? K square equals to 16 and k equals to plus minus,
Equals to 4.
right? Plus minus 4. So this means that for these values of k, you're going to have real and you're going to have real and equal roots. Does this make sense?
Yes, okay, sir.
Okay. So the meaning of this, the concept is that if the value of k is going to be plus 4, then your equation is going to be 4x squared plus 4x plus 1. Then your quadratic curve is only going to intersect the x-axis at one point. Or if your k value would have been -1, -4, then if you were to plot the graph, your curve is going to be intersecting the x-axis at only one point. So for these values of k, we are going to have real and equal roots. Do you understand this?
So, sir, that means if it's negative or positive, they both will intersect at the same point.
No, they are not intersecting at a same point. This so if I okay, this is the equation. Okay, I want you to give me the roots of this equation.
4.
Roots, the x-intercept, the x-intercept.
Is positive 4.
Okay, no,
Is positive 4.
it's -1/2. I mean, you have to solve this equation and find me the x-intercept.
Okay, okay.
So if you factorize this or apply the quadratic formula, you're going to get only one value of x, that is -1/2. And for this equation, you're only going to get
1/2.
+1/2. Okay.
Okay, I understand, sir.
Now, do you understand? But the question was, we just have to find the value of k for which we are going to have two equal roots. So if you want two equal roots of a quadratic equation, the discriminant of a quadratic equation must be equal to 0. If that is the case, plug in the values of a, b, and c in the equation and solve for k. K value comes out to be plus and minus 4. The values of k are plus and minus 4 when the discriminant was set equal to 0. The discriminant was set equal to 0 because we wanted two equal roots. Is this thing clear?
Yes, sir.
Okay. Now, find the values of k for which x squared minus 5x plus 9 equals to k times 5 minus x has two equal roots. Again, if the equation has two equal roots, what can you say about the discriminant of the equation? The discriminant of the equation should be equal to 0, right?
Equals to, yeah.
0. Okay. So the first step, how would you solve this equation? You're going to simplify. X squared minus 5x plus 9 equals to k times 5 is 5k minus k times x is minus kx. And you're going to rearrange the equation in the form of y equals to ax squared plus bx plus c. So bring all the terms on the other side. X squared minus 5x plus kx plus 9 minus 5k equals to 0. Rearrange this equation. Can I write it as plus kx minus 5x is the same thing? Now, if I take x common, the coefficient of x is going to be k minus 5 plus 9 minus 5k equals to 0. Are you both with me till here?
Yes, sir.
Okay. Do you understand this step? Zohaib, are you following? Zohaib, are you also following till here? Okay. So x squared plus k minus 5 times x plus 9 minus 5k. The coefficient of x squared is 1. Just compare this with ax squared plus bx plus c equals to 0. The value of a is 1, the value of b is k minus 5, and the value of c, the constant term, is 9 minus 5k. Now, what must be the values of k if I want this equation, which is now simplified to this equation? This equation must have two equal roots. If I have this equation, what can I say about the discriminant of the equation if I want two equal roots? Do you agree that it's going to be the discriminant, which is b squared minus 4ac, would be equal to 0, right? So b squared minus 4ac, which is the discriminant of a quadratic equation, should be equal to 0. What's the value of b? K minus 5. What is the value of a? 1. And the value of c is 9 minus 5k. I am going to solve this equation now. This is going to be k squared minus 10k plus 25 minus 36 plus 20k. So k squared plus 10k minus 11 equals to 0, right? K squared plus 10k minus 11. Now solve this equation for k. You can use factorization or you can use quadratic formula. Give me the two values of k. Okay, do we have the values? How do I solve this quadratic inequality? First of all, I'll have to find the critical values. I can take 4 common. It's going to be k square minus 8k, 8k greater than 0. It reduces down to k square minus 8k greater than 0. Then I can factorize this and I'm going to get k times k minus 8 greater than 0. These are the factors. Guys, if these are the factors, what are my critical values going to be? This is what we discussed in the last class, finding critical values and help and solving quadratic inequality. If this would have been an equation, what would have been the x-intercepts? K times k minus 8. So what would have been x-intercepts? Yeah,
K is equals to 0 and K is equals to 8.
right. K equals to 0 and k equals to 8. Now, but this is not an equation, it's a quadratic inequality in terms of k. This equation is the quadratic, this part over here is a quadratic inequality. So one value is 0, the other value is 8. Do I want this quadratic inequality, do I want this quadratic curve to be above the x-axis or below the x-axis? I want it greater than 0. Am I shading the right region? This is where the graph is above the x-axis, right?
Yes, sir. Yes, sir.
So what should be my range of values of k? What should be my range of values of k?
X is
K,
K is greater than uh equals to 8 and smaller than equals to 0.
okay, because in the original question it's greater than, okay. So I'm just going to write k less than, because the value, this value itself is not included. So it's going to be k less than 0 or k greater than 8. That should be your answer for this quadratic inequality.
Yes, sir.
Okay. Is everyone with me till here?
Yes, sir.
Okay. Now, if I just slightly adjust this question and I say that I want, if the question would have been k square minus 2kx plus 8 equals to 0 has equal roots, then how would the working be different? If it would have said equal roots, guys, then the discriminant b square minus 4ac would be, Abdul Rahman, what will it be? If the question would have said that this equation has equal roots, then what about the discriminant of this equation? You would have said b square minus 4ac equal to 0, right? Yes or no?
Yes, sir.
So now you would have done exactly everything similar to what we have done in the first part, and you are going to end up getting k times k minus 8 equals to 0. So what are going to be the values of k? Because this is now an equation, what are the values of k for which you are going to have equal roots?
Positive 8 and minus 8.
Positive 8 and 0, right? K is 0 and k is 8. These are the two values
Yes, yes.
of k for which you are going to have equal roots. Now, if the question would have been find the range of values of k for which kx square minus 2x minus 2kx plus 8 equals to 0 has no real roots. How would your working be different then? How would you have started your question?
No real root.
No real roots means that this quadratic equation will have a discriminant greater than 0, equal to 0, or less than 0. Come on, guys, tell me.
Greater than
Less than 0.
greater.
Less than 0, beta. Because no real roots. When we have two distinct roots, then the discriminant was greater than 0. When we have two equal roots, then the discriminant
Yes,
is
sir.
equal to 0. And when we have no real roots, then the discriminant is less than 0. Okay. So if I would have plugged in the values of B, A, and C, I would have gotten the same equation, right? It's the same equation. Is this so? If I would have simplified this, I would have ended up with this. I know what my critical values are, right? You have already told me. But this time the inequality is different. Critical values are same, K0 and K8. But what are the values? What should be my range of values of K now for this particular question? 0 and 8. What should be my range of values of K? I want this curve to be less than 0. So for what values of K is my curve less than 0? K greater than 0 and less than 8. Do you agree with me? Are you following till here, or is there any difficulty? Please let me know right now so that I can clear your concepts.
No, sir. Thank you.
Abdurrahman, do you have any questions?
Sir, could you repeat the last part?
Yes.
The internet was lagging on my side.
Okay, I'll repeat. So we found the critical values because it's the same equation. The discriminant expression is going to be the same. The only difference is that this time it's less than 0. The critical values are also same. You're going to find for what values of K is my curve going to be below the x-axis. So this is the region. So the inequality answer is going to be K greater than 0 and less than 8. That's the answer. So we have done
Okay, sir.
three cases. If the roots are if you were being asked to find the range of values of K for which this equation will have two distinct roots, that means real and distinct roots. So the discriminant is going to be greater than 0. You plug in the discriminant expression and factorize it. You found the critical values, and then based on this sign, you decide which region is the required region. So because it's greater than 0, I want this region above the x-axis. So that's why the range of values of K is going to be less than 0 and greater than 8. If I use the same equation of the question, but this time it says find the values of K for which it has two equal roots. So when does a quadratic equation have equal roots? When the discriminant is equal to 0. So I'm again going to write down the expression of b square minus 4ac, which is the discriminant. Plug in the values, factorize it. I'm going to end up getting the same result, K times K minus 8. But this time it's an equation equals to 0. So the two values of K are going to be K equals to 0 and K minus 8 equals to 0. Hence K is 8. So K equals to 0 and K equals to 8. These are the two values for which you are going to get equal roots. Then I said, what if the question would have been that find the range of values of K when the same equation does not have any real root? So if this equation will not have any real root, that means the discriminant must be less than 0. Apply plug in the values of A, B, and C in the discriminant expression. You end up getting the same result because it was the same equation. You factorize it and you get k times k minus 8. The critical values are going to be the same 0 and 8, but this time you want to find those values of k for which your curve is going to be less than 0. Less than 0 means this region below the x-axis. So the values of k that are going to be acceptable are from 0 to 8. So k must be greater than 0, less than 8. Is this concept clear to everyone?
Yes, sir.
Let me know
Yes, sir.
if I want to repeat if you want me to repeat anything.
No, sir.
Okay. Okay. All right. Done till here. Have you noted down the working as well? Just take a screenshot if you want and then note it down.
Could you send this after after the class?
Okay, I can. All right. Then if the question is find the range, find the range of values of k for which the equation kx squared minus 5x plus 2 equals to 0 has real roots. Now, what do we mean by real roots? Anyone? Real roots का क्या मतलब है? What is the meaning of real roots? Real roots means that my quadratic curve can either have real and distinct roots or it can have real and equal roots. Because in both the cases, the roots are real, right? So either it could be this possibility or it could be this possibility. Either I can have real and distinct roots, meaning two different roots, or I can have real and equal roots because in both cases, both of these cases, uh, the roots are real. What do we mean by roots real? The graph intersecting the x-axis somewhere. Okay. So for real and distinct root, I know that the discriminant of the equation must be greater than 0. And for real and equal root, I know that the discriminant of the equation must be equal to 0. But here the question says real roots only. So this means that there are two possibilities. Either the discriminant is greater than 0 or it can also be greater than or it can be equal to 0 as well. So that's why when you begin this question, you're going to take discriminant of this equation to be greater than equal to 0 because this equation has real roots. When the question says real roots, it can be both. It can be real and distinct as well as it can be real and equal. Now your equation was the equation was kx squared minus 5x plus 2 equals to 0. Is it arranged in a general quadratic form of ax squared plus bx plus c? Is it already arranged? Yes or no?
Yes, sir.
Yes. So the value of a, the coefficient of x square is k. The value of b is -5 and the value of c is 2. Now apply the discriminant formula b square minus 4ac. The discriminant of this equation will do you agree that it's going to be greater than or equal to 0 now? Because as I said, there can be two cases. Either the roots are real and distinct or they are real and equal. So b value is -5, a value is k, c value is 2. So 25 minus 8k greater than or equal to 0. So what must be the range? What must be the range of values of k then? Solve this inequality and just give me the answer. Come on, quickly. 25 greater than or equal to 8k which means 8k is less than equal to 25 and k less than equal to 25 by 8. Are we all getting the same result? Let me know.
Yes, sir.
Yes, sir. The answer is
But we
3.12.
prefer leaving it in fractions, okay? K less than equal to 25 by 8. Okay. Now try this question. You need to prove that the roots of the equation 2kx square plus 5x minus k equals to 0 are real.
Sir,
Yes.
could you just give me a minute for it done?
Okay. Sure. Okay, I'll continue after that. Now, in this question, you need to prove that the roots of the equation 2kx square plus 5x minus k equals to 0 are real and distinct for all values of k. Now, let's try to understand the question. This question means that you need to prove that the roots of this equation are going to be real and distinct for all values of k. No, that means that no matter what value of k you put in, the roots of this equation are always going to be real and distinct. Now, the roots of this equation are going to be real and distinct when the discriminant of this equation is always greater than 0. So you need to show, if you can successfully show that the discriminant of this equation is always going to be greater than 0, then this means that you have proved that the roots are going to be real and distinct. So how to go about this question? You're just going to write b square minus 4ac and plug in the values, because right now you are not going to say that it's greater than 0, it's equal to 0, it's less than 0. You need to prove that in this question. So you're just going to write down the discriminant expression b square minus 4ac. B value is 5, A value is 2k, and C value is minus k. Okay, so that is 25 minus 8k square. Sorry, plus 8k square. Right? So 25
Sir.
plus 8k square. Now, think it like this. Whatever value of k you plug in, either negative or positive, after after being squared up, will this answer will always be positive? Yes or no?
Yes.
When you multiply by this 8 plus 8, then this value added with 25, this means that this answer 25 plus k 8k square is always going to be positive. So you, as a conclusion, you are going to say that 25 plus 8k square is always positive for all values of k. Therefore b square minus 4ac is always greater than 0. Hence the roots are real and distinct. Okay, the roots are real and distinct because whatever value of k I plug in, after being squared up, this answer is always going to be positive. When I add 25 to it, it's still positive. So no matter what value of k I plug in, this value is always going to be greater than 0. If the discriminant value is always going to be greater than 0, then that means that the roots are going to be real and distinct always. Okay, understood how to
Yes,
do?
sir.
Okay, let's try another one. Similar question. Prove that the
Sir,
root.
in exam,
Hmm,
sir, in exam, do we need to write this is always positive for all values of k and therefore?
yes, you are going to write down a statement like this. Now you need to prove that this equation x squared plus k minus 2 times x minus 2k equals to 0 are real and distinct for all real values of k. This is another way they can ask the same question. I'm going to copy it on a different slide. Prove that the roots of the equation x squared plus k minus 8. Just a second. Prove that the roots of the equation x squared plus k minus 2 times x minus 2k, this is k, equals to 0 are real and distinct for all real values of k. First of all, please understand that you have to prove that the roots of this equation are real and distinct for all values of k, means whatever value of k you plug in. For all, yes, Wave, only you were disconnected. Okay, I'm doing this question. If you have any query, let me know. Okay, I'll explain it again. So prove that the roots of this equation are real and distinct for all real values of k. You have to prove the equation is x squared plus k minus 8 times x minus 2k. Can you guys tell me what is going to be the discriminant expression? What is going to be the discriminant of this equation?
Sir, wait, you wrote in the question x squared plus k minus 2, not k minus 8.
Yeah, this is k minus 2 times x. This is x.
Yes, but in the you're solving x squared plus k
Yeah,
minus 8.
yeah, that's my fault. Okay, now fine. K minus 2. Okay. Now I want you to write down the discriminant expression for this equation. B value is going to be k minus 2 whole square minus a value is going to be 1. C value is minus 2k. Now, do you notice that I'm not putting any sign of the inequality? Because I want to prove that it's always going to be positive. Because if I want to show that it's going to be real and distinct, it means the answer must always be positive. So I'm going to simplify this k minus 2 the whole thing square plus 8k. Okay, now I'm going to further simplify this k square minus 4k plus 4 plus 8k, k square plus 4k plus 4. All right, clear with this? Is everyone with me till here?
Sir,
Okay, now at this step, I want you guys to make the completing square form of this. Because from this form, I cannot tell that whatever value of k I'll plug in, it's always going to be positive. So the better way is to go for a completing square form for this. And you are going to notice that the completing square form is going to be k plus 2 the whole thing square for this. Now, I have written it as a completing square form. Now tell me, whatever value of k I plug in for all real values of k, okay? So whatever value of k I plug in, will this answer, after being squared up, will this answer always be positive or not?
yes, sir.
Yes, sir.
Okay, this answer is always going to be positive. So as a statement, I'm going to write k plus 2 the whole thing square is always positive. Or you can write greater than 0. Therefore, b square minus 4ac is greater than 0. And if b square minus 4ac is greater than 0, you're going to say that hence the roots are always real and distinct for all values of k. Why didn't you simplify the equation given in the question? I don't need to simplify the equation because this is the simplified form. Remember that in order to deal with these questions, the equation must be in the form of ax square plus bx plus c. So it is in the form of ax square plus bx plus c already. So I don't need to simplify that. Okay. Do you get, guys, do you get it?
Yes, sir.
Okay. I'll post the homework questions for this as well, and I want you to complete the last homework questions as well. Okay. Take care. If you have any questions, I can wait and answer your queries. Multiplying the brackets. Yeah, that's what I'm trying to say. Zoeb, if I am going to multiply the brackets with x, so it's going to be kx minus 2x. This, so there is no one term in x. I want one term in x so that I can get the coefficient of x. That's why I'm going to take x common out and I'm going to write it like this. Now is it clear?
Yes, sir.
Because I want the value of b, the value of b is going to be k minus 2. Okay. If you
Sir,
have,
if it will be 2, then उससे क्या होगा फिर अगर 2 कर देते हैं तो
कहाँ पे? Where?
ब्रैकेट्स को मल्टीप्लाई करके आप बोल रहे हैं ना 2x आ जाएगा.
So x square plus kx minus 2x minus 2k equals to 0. You have to apply the discriminant. What is the value of b over here? What is the value of b?
k minus 2.
So k minus 2, right? So you must write this as ax square plus bx plus c form. So over here, I just need one coefficient of x. So I will have
Oh,
to
okay.
take x common.
Yes.
Okay. All right. Take care.
अल्लाह
Bye-bye.
हाफिज.
No.